Hi, and welcome to our discussion on calculating the area of some of these simple shapes. We just went through the PowerPoint 5.1 on geometric properties of these shapes. So we have all of our calculations or all of our formulas that we need, but they didn't really go through any examples. So I'm going to go through a few examples of how we can use these. A lot of this is review from your math class, but it's still some good stuff to see, especially for the practice problems that are coming up. So I've got all of our shapes that they talked about drawn out here, and I've got a couple different problems that we're going to go through. So this might end up being a little bit of a long video, but you feel free to skip ahead and skip around to whatever you think is your need. So starting with the circle, we have our equation is pi times radius squared. So if I have a circle here and my first problem says my radius is 4 inches, let's just go ahead and see how we plug that in. Mostly I just want to make sure that we see how we do it in our calculator. And so you can use 3.14 if you would like. I like to use pi just because I think it's more accurate. It's really up to you. So in my calculator I make sure that for area I will type in pi times, and if you want to make sure everything is the way it's supposed to be, put it in parentheses. So 4 squared, pi times 4 squared, since my radius was 4. And when I do that, I get my answer of 50.27, let's say. Let's round. 50.27 inches squared. Always make sure you are labeling as inches squared. Okay, so let's look at our second problem. If I have my area is equal to 16 inches squared, I need to find the radius. How do I solve for that? Well, we're going to do our algebra and say area equals pi r squared. So 16 is equal to pi r squared. So let's divide. To solve this, the first step we need to do is divide by pi on both sides. So we'll have 16 divided by pi is equal to r squared. So how do I get r by itself? I need to take the square root. You undo a square with a square root. So I'll write it this way now. R is equal to the square root of 16 divided by pi. So in your calculator, if you have a square root button, make sure you're using your parentheses properly. So I will do second, and I will do square root of 16 divided by pi. Make sure I close off that parenthesis, and so it'll do the square root of that whole problem there, and I get my radius to be 2.26, let's say with rounding, 2.26 inches. Again, don't forget your label. Labels are part of the answer, and if you don't use your labels, you will get the answer wrong. Okay? So that is our circle. Moving on to the ellipse. I have an ellipse here, not a good one, but it's good enough for our purposes. I'm given the major axis of 6, a minor axis of 2. If I look at my equation, I have area is equal to pi times A times B. Well, A is part of my major axis equation, but my major axis is 2 times A. So if I'm going to plug in what I have, I need to say pi times, if my major axis is 6, I need to make sure I do 6 divided by 2. B is my minor axis. Well, 2B is actually my minor axis. So if I want just B, I need to take my minor axis divided by 2. So 2 divided by 2. So if I do all of that, I say pi times, if you don't know what 6 over 2 is, plug it in. 6 over 2 times 2 over 2. And I should get something around a 9. Yep, 9.42, let's call it. 9.42 inches squared. So there's my ellipse. Again, make sure if you're given a major axis or a minor axis that you are dividing by 2. If you need to solve it the other way, you need to actually multiply by 2 at the end to get to your major or minor axis. Okay, triangle. Triangle's pretty straightforward. I've got a triangle with a base of 8 and a height of 16, so let's just do my problem. So BH over 2 is equal to my area. So area equals 8 times 16 divided by 2, or 1/2 times 8 times 16, however you want to say it. So I'll take 8 times 16 divided by 2, and I get 64 inches squared. That one's pretty straightforward. You guys have seen that probably many times over. Parallelogram covers my rectangles, it covers my squares, but it also covers my shapes like this, which is a parallelogram. So if you have a parallelogram like this, remember that your base is simply whatever the widest point is on the bottom or the top, and then your height is the distance from the bottom or top of that. So if I have area is base times height, I have 3 times 10, so my area is equal to 30, and I'll just say those are inches. 30 inches squared. Okay? Pretty easy. Now, sometimes you're going to get a problem like this, where you have a circle with a square inside of it. And what did we call that? Well, if we look back from our presentation, a circle with a square inside of it is considered inscribed. So there's a circle with an inscribed square inside of it. So when I have a circle with an inscribed square and I'm given the radius of the circle, I'm given the base and height of my square, what is the area of the shaded space that's left over? So if my circle is solid and my square is the whole, I need to find the area of the shaded space. So what I can do is I take the area of my solid space and subtract the area of my open space. So let's say that again. I have a solid circle and I've cut a square hole out of it. I want to know what the leftover area of my circle is. So I take the whole circle minus the square. So area of circle minus area of square. So I have pi r squared minus base times height, pi times 2 squared minus 1.5 times 1.5, and if I take that and do everything in my calculator, let's see how I could do it all at once. Okay, I want to make sure we see this. Those of you that use your calculators and try to plug it all in at once, make sure you're using your parentheses properly. So I'm going to do a parenthesis, and I'm going to take pi times, my radius was 2 squared, close parenthesis, minus 1.5 times 1.5, close parenthesis. So make sure you have your parentheses around all of your work there. And when you do that, your answer is 10 point leftover area is equal to 10.32 inches squared. Okay? So again, just make sure if you're using your calculator and doing it all, you are taking your time and using your parentheses properly. If you want to do this and write that answer down and then do this and write that answer down, that's probably a safer bet, but I wanted to show if you're using your calculator how you could do that. All right, finally, we've got a little bit of a different equation here with our regular polygon. Now, a regular polygon, as a reminder, means we have a polygon, a shape with any number of sides, and all of those sides are the same length. So in this case, I have a hexagon with 1, 2, 3, 4, 5, 6 sides, and I know my side length is 3 inches for every single side. That makes it regular. So what do? I take n times s squared. So n is the number of sides, so I have 6 times 3 squared divided by 4 times the tangent of 180 divided by 6, the number of sides. Tangent is a geometric calculation, a geometric property of triangles, and we're not going to cover that right now in this class. If you haven't seen it in geometry yet, that's okay. Just know that tangent is a button, or it might be a second function on your calculator. So on mine, it's under the second function, it's the blue one, tan. So I'm going to take 6 times 3 squared to get 54. 6 times 9 is 54. And I'm going to divide that, and I'm going to show you if I do it all on my calculator. Once again, let's make sure you can see it. By 4 times tangent of 180 divided by 6. And again, I need to make sure I use my proper parentheses. So 180 divided by 6 is a parenthesis, and my last parenthesis closes off what I'm doing there. So I get my answer of 23.38 inches squared. Now I want to show you one more thing. If you are using your cell phone, which I know a lot of you do, you have to do something a little bit different. Okay, so if you're using your cell phone and you're doing that tangent calculation, maybe it's going to have a hard time showing up. It's just because my phone went dark because I was slow. Okay, so if you're using your phone to do your tangent calculation, you have to be careful here. When I type 4 tan, that actually is taking the tangent of 4. So that's not the same thing as what we're doing, because this equation here is saying 4 times the tangent. But if you hit 4 tan, that is taking the tangent of 4, and that's not what we want. So you need to make sure that you do 180 divided by 6, so you get 30, and you want to take, so you use 30, and then you use tan, and you take that times 4. To get your number there. So if I remember 2.309, then I can take 54 divided by 2.309, and then I get my same 23.38. So just remember that if you're using your phone, if you hit 4 tan, that's like saying you're taking the tangent of 4, which is not the same thing as what we're doing here. So just be careful if you're using your phone as a calculator that you are doing things in the proper order. All right, last problem. So let's say I have this regular polygon and I am given the area. How do I find my side length? So here again, if you haven't used tangent before, is where it can get kind of tricky. So my area is 20, and that is equal to, if I have ns squared, my number of sides is still 6, so 6 times s squared divided by 4 times the tangent of 180 over 6. Okay? So to find my side length, I need to first do this portion down here. So let's do 4 times the tangent of 180 divided by 6. I get 2.309, just like I did before when I was doing my problem. And I'm going to take that times 20. So times 20, because if I'm going to go from the bottom of my fraction over here, I need to multiply it on this side and multiply it on this side. So I have 46.18, or 19, let's say, is equal to 6 times s squared. Well, how do I get my 6 out of there? I need to divide on both sides, so I'll take that divided by 6. 7.698 is equal to s squared. So to get rid of both, I take the square root. Square root of 7.698 is s. So s is equal to second square root of this, and I get my side length is 2.77 inches. So that is how you would go about doing the calculation if you needed to find the side length. First you figure out the bottom portion of your equation, then you will multiply that over, then you'll divide by however many sides there are, and then you'll take the square root to get your ultimate final answer. So there's some examples that go along with our equations. Use them to do your practice problems. If there are still questions, I will always be around to help, but this video is available at any time. Take it easy, pause when needed, and good luck.